Let's look at another example here of function notation. Let's read. Consider the symbolic rule t equals 3h minus 8. Here, t is a function of h, so I should verify that for you, that t is a function of h. In other words, each input value has one and only one output value assigned to it. And you can plug in a 3 and calculate a number, and if you come back later and plug in a 3, you're going to get that same number, just the way this is defined. So this is a function. This equation fully describes a function relationship between t and h. But that's not what we want to do. We want to do part A here. Rewrite the symbolic rule, this equation here, into function notation. Now take a look at this. Use t as the function name. Well, t in the original equation is the output variable, and oftentimes when we translate an equation into function notation, we use that same guy as the function name. Alright, so in function notation, we have a set of parentheses, an equal sign, and when we are translating an equation into function notation, again, this first area is the function name, which the problem told us to use t, so we're going to use t there. The inside here goes the input variable. So which one is the input variable here? Is it t or h? Good. Hopefully, I think I heard you say h. Yeah, h is the input variable here, and then on the right side is the expression that calculates output values given an h value. So what expression up here calculates our output values? And so that guy does it, 3h minus 8. So this now is in function notation. The function name is t, and t says take h and then do these calculations to it to get your output values. And now here's the interesting thing. T is no longer the output variable, it's just the name of the function. The output variable is actually this whole thing, t of h. Again, this is pronounced t of h, and this is the output variable, and that's the input variable. So we're going to do a couple of items here using this function now in function notation.